You think you understand the early universe, a hot, dense fireball, expanding and cooling, allowing the first atoms, then stars and galaxies to form. A tidy chronology from simplicity to complexity. A universe that built itself, one orderly step at a time. But this is where physics gets strange. Astronomers have spotted galaxies that shouldn't exist. Not just old, impossibly old. Massive structures churning out stars when the universe was still an infant. But it gets even more disturbing. These anomalous galaxies aren't just isolated oddballs. They're everywhere, littering the early universe like monuments to our ignorance. The more we look, the more we find. Mocking the models astronomers spent decades refining. And it's not just the timing that's wrong, it's the scale. Our first galaxies were supposed to be small, scrappy collections of stars and gas, slowly merging and growing over billions of years. But these primordial beasts are already monstrous, matching the most massive structures in the modern universe. It's as if they skipped straight to adulthood, bypassing the awkward adolescence our theories demand. So what's going on? The shocking truth is that astronomers have no idea. Standard models of galaxy formation simply can't explain what we're seeing. The physics doesn't add up. Something is missing from our understanding of the early universe. Something big. But this failure is also an opportunity. Because to solve this cosmic puzzle, we can't just patch up the old theories. We need to strip our assumptions back to the bedrock and rebuild. And when we do, we may find that the early universe was a far wilder and more interesting place than we ever imagined. Forget the clockwork cosmos ticking forward on a predictable schedule. The old rules are collapsing. We're confronting a universe that defies classical intuition at every scale. A quantum universe, where the seeds of cosmic structure are sown in the fabric of spacetime itself. Where information, not just matter, shapes the evolution of the cosmos. What NASA didn't tell you is that the first galaxies aren't just another data point. They're a fundamental challenge to everything we thought we knew about the cosmos. They're a mystery that could force us to rewrite the laws of physics. And the journey to solve it will take us to the edge of reality itself. Before we go any deeper, I need to ask you something. If you're here for comfort, this isn't the channel for you. But if you're here for truth, even when it's unsettling, take a second to support this mission. Hit like, subscribe, and leave a comment telling me what part of reality shocked you most. Every interaction tells the algorithm that depth matters more than distraction and that thinking clearly still has value. If you want to keep tearing apart reality with me episode after episode, make sure you're following. We're just getting started. So what exactly are these cosmic rule breakers that have astronomers scratching their heads? Meet the quasars, the universe's ultimate rebels. Quasars are galactic engines gone berserk, spewing out energy on a scale that dwarfs entire galaxies. They're powered by supermassive black holes, monstrous gravity wells millions or even billions of times heavier than our sun. But here's the catch. Quasars aren't just bright, they're ancient. Astronomers have spotted quasars lighting up the cosmos when the universe was less than 1 billion years old. And this changes everything. You see, building a supermassive black hole isn't like microwaving a burrito. It takes time, cosmic time. To grow that massive, a black hole needs to gorge on gas and dust for hundreds of millions of years. It needs a vast galaxy to feed it, with enough raw material to fatten it up to monstrous size. But here's the problem. In the standard model of the early universe, those vast galaxies simply don't exist. They haven't had time to form. The raw material is spread too thin, scattered across space in a diffuse haze of hydrogen and helium. Astronomers have precise formulas for how long it takes cosmic structure to grow, and they all say the same thing. You can't build a quasar in the time available. The numbers don't add up. So what are these monster black holes doing in the primordial cosmos? How did they get so big so fast? The truth is, nobody knows. It's a mystery that strikes at the heart of our understanding of the universe. But it gets even stranger. Because quasars aren't just freakishly large, they're also freakishly common. The early universe is littered with them, shining from every corner of the cosmos. It's like stumbling into a daycare center and finding it full of NFL linebackers. They're not just big, they're everywhere. And this is where the real trouble starts. Because if quasars are common, then the supermassive black holes that power them must be common too. And if supermassive black holes are common, then the vast galaxies needed to grow them must be common. In other words, the universe must have built itself faster and more efficiently than any of our theories predict. But how? What cosmic accelerator put the universe on steroids? The answer may lie in a radical rethink of the laws of gravity. Some physicists are now suggesting that gravity itself may behave differently in the early universe, that the same force that keeps your feet on the ground also gave the cosmos a turbo boost, fast-tracking the growth of stars and galaxies. It's a wild idea, one that takes us far beyond the comforting certainties of classical physics. But if it's right, it could solve the quasar conundrum and rewrite the story of cosmic evolution. It would mean that the early universe was a place where gravity went haywire, where the normal rules of attraction broke down and structure bloomed on an impossible scale. Of course, this is just one idea among many. The truth is, we're only beginning to grapple with the profound strangeness of the early cosmos. But one thing is clear. The universe isn't just stranger than we imagine. It's stranger than we can imagine. And the quasars are our guides into that uncharted territory, the signposts of a cosmos beyond our ken. So buckle up and keep questioning, because the journey to the edge of the cosmic map has only just begun. And if you're ready for another dose of mind-bending physics, hit the follow button for the next part of our journey into the unknown. But the mystery of the early universe isn't just about what we see, it's about what we don't see. And this is where the cosmic puzzle takes a truly mind-bending turn. Because when astronomers stare into the primordial cosmos, they see a universe that's missing something fundamental, something so basic to our understanding of reality that its absence is almost impossible to comprehend. That missing piece is antimatter, and its disappearance is the greatest heist in the history of the cosmos. To understand why, we need to take a step back and look at the basic building blocks of the universe. Everything you see around you, from the screen you're reading this on to the air you breathe, is made of matter. Protons, neutrons, our electrons, the tiny particles that combine to form atoms and molecules and all the complex structures of the cosmos. But for every particle of matter, there's a twin, an evil doppelganger that's identical in every way, except for one crucial difference. It has the opposite charge. These antiparticles are the mirror image of the material world, a shadowy realm where electrons are positive, protons are negative, and everything is backwards and upside down. And here's the thing. In the early universe, matter and antimatter should have been created in equal amounts. For every proton, an antiproton. For every electron, a positron. A cosmic yin and yang, locked in a delicate balance. But when astronomers look out into the cosmos, they see a universe that's almost entirely made of matter. Antimatter is nowhere to be found. It's as if the universe started with a full deck of cards, but somewhere along the way, all the black cards vanished, leaving only the red ones behind. And this is where the real headache starts, because according to the laws of physics, matter and antimatter annihilate each other on contact. They cancel out in a flash of pure energy, leaving nothing behind. So if the early universe was perfectly balanced with equal parts matter and antimatter, then it should have annihilated itself almost instantly, leaving behind a sea of radiation and nothing else. But that's not what happened. Instead, the universe survived, and not just survived, but thrived, growing and evolving into the vast cosmic web we see today. Somehow, the cosmos cheated the laws of physics and tipped the scales in favor of matter. But how? The shocking truth is that we have no idea. The disappearance of antimatter is one of the deepest mysteries in all of physics, a cosmic whodunit that has stumped generations of scientists. We've searched high and low for some asymmetry in the laws of nature, some fundamental difference between matter and antimatter that could explain why one triumphed over the other. But so far, we've come up empty-handed. Some theorists believe the answer may lie in the mind-bending realm of quantum mechanics, the strange and counterintuitive physics that governs the subatomic world. In the quantum realm, particles can pop in and out of existence, and the normal rules of cause and effect break down. It's a place where the impossible becomes possible, and where the seeds of the universe's imbalance may have been sown. Others believe the answer may lie in the even stranger realm of string theory, the idea that the fundamental building blocks of the cosmos aren't particles at all, but tiny vibrating strings of energy. In the funhouse mirror world of strings, the laws of physics can twist and deform in ways that defy classical intuition, and just maybe in ways that could explain the triumph of matter over antimatter. But the truth is, these are just guesses, educated guesses, but guesses nonetheless. The great antimatter heist remains unsolved, a cosmic mystery that cuts to the heart of why we're here at all. Because without that primordial imbalance, without the universe's strange and seemingly arbitrary preference for matter over antimatter, we wouldn't be here to wonder about it. So the next time you look up at the night sky, remember you're looking at the scene of a crime, a cosmic caper that left the universe lopsided and us scratching our heads. But don't despair, because in the grand tradition of all great detective stories, the clues are out there, waiting to be found. And as we'll see in the final part of our journey, those clues may lead us to a truth stranger and more profound than anything we can imagine. If this peek behind the cosmic curtain left you hungry for more, smash that follow button and buckle up, because in part 4, we're going to take on the biggest mystery of all, the ultimate fate of the cosmos itself. And trust me, you won't want to miss it. So far, we've seen how the early universe defies explanation, how the impossible existence of ancient galaxies and the baffling absence of antimatter challenge our most basic assumptions about the cosmos. But as strange and unsettling as these mysteries are, they pale in comparison to the ultimate question, the one that's haunted astronomers and philosophers alike since the dawn of time. What is the fate of the universe itself? How will the cosmic story end? For decades, the answer seemed clear. The universe was expanding, the distant galaxies fleeing from each other like shrapnel from a primordial explosion. And that expansion was slowing down as the collective gravity of all the matter in the cosmos put the brakes on the cosmic expansion. Astronomers could even predict the end state, a universe that would either collapse back in on itself in a reverse Big Bang or coast to a stop, freezing out in an endless expanse of darkness and cold. But just when we thought we had it all figured out, the universe threw us a curveball. In the late 1990s, astronomers made a discovery that shook the foundations of cosmology. The expansion of the universe wasn't slowing down at all. It was speeding up. Somewhere out in the cosmic depths, a mysterious force was pushing the galaxies apart, a force so strong and so baffling that it seemed to defy the laws of physics themselves. Astronomers gave it a name, dark energy, but the name was little more than a placeholder for their ignorance. Because the truth is, we have no idea what dark energy is. Is it a new kind of particle, flooding the cosmos like an invisible mist? Is it a flaw in our understanding of gravity? A crack in the foundation of Einstein's general relativity? Or is it something even stranger, a relic of some long-forgotten phase transition in the early universe, or a sign that our cosmos is just one of an infinite multiverse of parallel realities? The shocking truth is that all of these ideas are on the table, and all of them are equally terrifying, because if dark energy is real, then the fate of the universe itself hangs in the balance. In a universe dominated by dark energy, the expansion of the cosmos will never stop. The galaxies will fly apart faster and faster until even the atoms themselves are torn asunder. Stars will blink out one by one until the cosmos is nothing but a sea of darkness and silence. A universe that's not just dead, but utterly devoid of structure and meaning. But even this bleak vision pales in comparison to the most mind-bending possibility of all. Some theorists now believe that dark energy may be just the tip of the iceberg, the first sign of a vast and terrifying instability in the fabric of reality itself. According to this idea, the vacuum of space isn't really empty at all. Instead, it's a seething ocean of energy, a turbulent sea where particles and antiparticles constantly pop in and out of existence like the foam on a storm-tossed wave. And just like a wave, the vacuum is unstable. It can collapse in on itself, unleashing a cataclysm of unimaginable proportions. If this happens, if the vacuum of space itself decays, then the consequences would be beyond comprehension. The laws of physics would break down, the constants of nature would drift and warp, and reality itself would come unglued. It would be a cosmic apocalypse, a collapse not just of matter and energy, but of the very fabric of existence itself. Of course, this is just speculation, a mind-bending thought experiment at the edge of our understanding. But It underscores just how little we truly know about the cosmos and how far we have to go to unravel its deepest secrets. Because the universe isn't just stranger than we imagine, it's stranger than we can imagine. It's a place where the impossible becomes possible, where the laws of physics break down and reality itself comes unglued. And as we've seen on our journey from the birth of the first galaxies to the ultimate fate of the cosmos, the more we learn about the universe, the more we realize just how much we have yet to understand. But that's the beauty and the terror of science. The knowledge that we are just scratching the surface of a reality that is vaster, stranger, and more profound than anything we can ever hope to comprehend. And as we stand on the brink of a new era of cosmic discovery, one thing is clear. The journey into the unknown has only just begun. So if you've made it this far, if you've followed the story from the impossible galaxies to the disappearing antimatter to the ultimate fate of reality itself, then congratulations. You're part of a select few, a tribe of cosmic explorers who dare to question everything, to push the boundaries of the known, and to stare into the face of the abyss itself. And if you're ready for the next stage of the journey, if you're ready to dive even deeper into the mysteries of the cosmos, then there's only one thing left to do. Smash that follow button, buckle up, and get ready for the ride of your life. Because where we're going, there be dragons. And the only way to find them is to keep pushing forward, to keep asking the hard questions, and to never, ever stop exploring. If you made it this far, you're part of the rare few who refuse easy answers and actually want the truth. If you want to keep dismantling reality with me and exploring the deeper structure behind everything we think we understand, make sure you're subscribed. Leave a comment with the question that's still bothering you, and let's keep pushing into the silence together.